This is Honors Algebra 2 Pre-Calculus. We're doing 10.6 in Pre-Calc, which is parametric equations. So how do we parameterize, which I always want to say is parametricize, like with an S or a C, but it's not. It's essentially parameter and then i's at the end. So how do we parameterize? Yeah, that's probably the way you say it. Parameterize equations. So really, sometimes books don't even bother using that crazy word. They just say, turn this system into a system of parametric equations, right? Or turn this equation into a system of parametric equations. So the short answer is that there's a really easy option, right? So the easy option is call xt and then replace the x's in the equation with t. That's the easiest way to do it, right? So you don't have to do that, but that's the easy option, okay? Like the mess with your teacher option would be to call t some like ugly combination of x's, right? So like ugly combo of x, right? Or actually, well, don't even have to go that way. You could do something like you could call x I meant to say it this way, some ugly equation of t's, right? So it doesn't matter, you could pick an ugly equation, right? And then you could replace the x's with whatever ugly equation you pick in the equation, right? So those are you know, there are other ways to do it. You could also call yt and replace the y's. But, like, really, this is by far the easiest option, right? So just to walk you through what that would look like, right, if we did an example 5, we're going to go ahead and pick x cubed plus 2y squared equals 3, right? And if I wanted to parameterize this, if I want to change this into a parametric equation, here's the easy way to do it, right? I'm going to say, oh, let's call x of t t. Great, that's half of it. Well, then that means that t cubed plus 2y squared equals 3, right? So if I solve for y, I'm going to get 2y squared equals 3 minus t cubed. Y squared equals 3 minus t cubed all over 2. So y is going to be plus or minus the square root of 3 minus t cubed over 2. So that's my other half of my equation, right? So my other half is y of t equals plus or minus the square root of 3 minus t cubed all over 2, right? So there's my parametric system in terms of t, right? And that's fine, right? Now notice I didn't even pick a very nice equation here. So here I picked one you still had to solve for y. I can pick a much easier example where we do the same thing. But again, notice that even with me just picking the simplest option for x, which was pick x is t, it's still a little bit ugly, right? So what I will say is in a situation like this, where I haven't solved for either of them, I could have picked either one of the letters to be t and then just solved for the other one. So let me actually show you an example 6, where in one case it's advantageous to call xt and the other it would be easier to call yt. So if we call this example 6, right? So 6a, I'm going to give you x equals y squared minus 4y, okay? And example b, I'm going to give you y equals 3x plus 7. Okay, so here's the deal. I have 2 examples and I'm going to parameterize each of these. In this situation, because it's already solved for x, it's easiest to say, hey, I'm just going to call y of t t, because y is already all the stuff on this side. That's just going to make x of t. I replace all the y's with t squared minus 4t. There are totally other right answers, but that's by far the easiest right answer. Same thing over here. This one's already solved for y, so it's easier to say, hey, let's just call x t. Well, then y of t is going to be a 3t plus 7, and I'm done. Now, when you look in the back of the book on problems like this, they're going to tell you there are infinite right answers, because the honest answer is that there are infinite right answers. So let's say, so this is by far, right, if we look at A, right, this was by far the easiest, and it was great. But let's say I decided to be a little bit crazy. Let's say I said, you know what, I'm going to call y of t, let's call it a 3t. Okay, well, if I did that, then everywhere I have a y in this equation, I'm going to have to replace it with a 3t. So x of t would be 3t quantity squared minus 4 times 3t. Now, is this system just as right as this system? Yeah, but this is harder, right? There was no reason to pick a harder one. right? I could do really crazy things. Like I could go ahead and pick, so if I wanted to pick something that's even harder than that, right? What if I said, you know what, I'm just going to call y of t, let's call it, I don't know, tangent of t, right? Call it tangent of t. Actually, I'm going to avoid tangent because tangent's iffy because it has a vertical asymptote and I don't really want to deal with it. So let's call y of t the sine of t. Well, then that would make x of t a sine squared of t minus a 4 sine of t, right? And there's nothing wrong with that. Again, that answer is just totally fine. So there are infinite right answers here. You just need an answer that works. By far the laziest answer is to assign one of your two main variables to just be t, okay? Same thing over here. I could have done all sorts of crazy stuff. Now, in the next video, we'll address what happens if your original equation has domain restrictions, because that would have some slight impact on this.